No século passado, a ideia do que seria o futuro começou como um exercício frívolo e até pândego. E foi se transformando aos poucos, passando do imaginário lúdico até chegar ao totalitarismo, à crueldade e à opressão. Neste século XXI, o futuro deixou definitivamente de ser visto de uma maneira romântica. Os olhares catastrofistas ainda estão por aí. Mas há também uma grande curiosidade em imaginar como o homem estará integrado à tecnologia. Reymond Coswell, engenheiro, futurólogo e visionário, trouxe para o campo mais do que concreto das possibilidades desse futuro mais palpável termos como transhumanismo e a famosa singularidade tecnológica, quando a humanidade dará um passo gigantesco no desenvolvimento tecnológico a ponto de mesclar a vida de carne e osso com a vida digital. No futuro de Kurzweil, homem e máquina estarão tão integrados que vamos misturar vida real e virtual. Nossa consciência não ficará mais limitada ao corpo físico. Poderemos transferir nossa mente para um computador e mandar fazer outro corpo. Enfim, estaremos muito perto da imortalidade. Kurzweil nos explica como e quando tudo isso deve acontecer nesse milênio especial em duas partes.
You fell in love with the computer when you were 12 and you built your first computer. Tell us about that. You wrote that for you it was like recreating the world.
Right. Well, I decided I'd be an inventor when I was 5 years old, and I didn't have electronics then. I had mechanical parts, and I had this feeling, I couldn't articulate it, that if you put things together in just the right way, you could recreate the world. You could solve problems. You could overcome human suffering. I didn't have any of that vocabulary as a 5-year-old, but I can remember the feeling. When I was 12, in 1960, I discovered the computer and felt you could simulate inside a computer just really anything. Music, intelligence, virtual reality, and I began to be fascinated with the computer. In the early 60s, I built my own computer, programmed it to compose music in the style of famous composers. My father got involved in that project. He was a musician. And that was really my first artificial intelligence project that won some international prizes. I got to meet President Johnson, and took that on a major network television program, I've Got a Secret. I played some music, and my secret was that I had built a computer that had composed the music.
Your father died early, right, of a heart attack, and your grandfather too. And you also had diabetes too, quite early, but you overcame that. So you have this, the odds are against you, but you beat them, right? And now your project is to extend your life. So tell us about that.
Well, I do have this idea from my family that you can find ideas that will overcome really any challenge. The ideas are out there, you can find them, and you should look for them, and when you find them, you should implement them. My interest in health started with the illness of my father. When I was 15, he had a heart attack. He died when I was 22. He was 58. And I felt that, I probably had inherited some of his bad genes for heart disease and diabetes. And when I was 35, I was diagnosed with type 2 diabetes. And the conventional medical approach actually made it worse. It's a long story why that is, but I decided, okay, I'll approach this as a problem, as an inventor and as a scientist. And I immersed myself in the scientific literature, and I came up with a unique approach involving nutrition and lifestyle and supplements, and overcame my diabetes. I've been free of diabetes ever since. And that really started me on this idea that you can confront health challenges just like you confront engineering problems. And I then confronted another health challenge, which was middle age, and the whole idea of aging, which is a biological process, but we can actually intervene already, not yet to completely stop it, but we can slow it down with today's knowledge. But the knowledge is accelerating. We'll get to a point not too far away where we will have the knowledge through biotechnology and nanotechnology to actually stop and reverse aging and disease processes, and they're really kind of mixed up with each other. And so that has been the mission that I've been on. I've written a series of books with Dr. Terry Grossman. First was called Fantastic Voyage. We have a new one called Transcend, 9 Steps to Living Well Forever. And the idea is to apply today's knowledge aggressively so that we can get to that future point where we'll have more knowledge. We call it a bridge to a bridge to a bridge. Bridge 1 is what we can do right now. And there's actually a lot more than you can do right now to slow down aging and disease processes.
We are the same age, but you are a few months older. But you look much younger than I do. How do you do that?
Well, I'm pretty aggressive. I spend a lot of time on slowing down the aging process. I take about 150 pills a day, and there's a different story on each one. It might sound like an aggressive program, but it's actually very conservative because I don't do anything that's at all controversial. Everything that I do there's a lot of scientific evidence that we talk about in our books. For example, human growth hormone is controversial, and I do not do that, and we don't recommend it because, well, it seems to slow down some aging processes. It also increases the risk of cancer. So I have a conservative program. I'll give you one example that's not well known. The cell membrane, the coating of every one of the 10 trillion cells in your body when you're young is made up of a substance called phosphatidylcholine. A child, 90% of the cell membrane is made up of phosphatidylcholine. That depletes as you get older. In an elderly person, someone who'd say 80, it's typically down to 10%. And the cell membrane gets filled in with inert, hard substances like hard fats and cholesterol. They're brittle. That's why the skin in an elderly person loses its elasticity. The organs don't work as well. That's an aging process. Aging is not one thing. It's a dozen different processes. This is one that you can easily actually reverse by supplementing with that particular substance. There's another aging process, atherosclerosis, which is the filling up of the arteries with plaque. That causes heart attacks, it causes strokes, but it also causes lots of other aging problems, infirmity in the limbs, claudication, impotence. All the arteries in the body get filled up with plaque at different rates depending on your genetic profile. That's one that we really understand quite well, and you can slow down and even stop. Dr. Dean Ornish has shown that you can actually reverse that. And that's not a matter of simply taking one pill. It's a complex, multifactorial process. You have to find out, is your cholesterol too high? Is your HDL, the good cholesterol, too low? Is your C-reactive protein, which is a measure of inflammation in the body, too high? Is your homocysteine too high, indicating a problem with methylation processes? We describe in our book how to diagnose the different aspects of this, and then you would do different things depending on what your issues are. Our program is not a one-size-fits-all. It's not a matter of just lower your carbs or lower your fat or eat a grapefruit a day. It's a matter of actually assessing where you are. If you're a healthy 22-year-old without any major issues, then you should just follow a healthy lifestyle, take some basic vitamins and minerals. If you're 50, 60, 70-year-old with diabetes and heart disease, and then you need to do more. But the common wisdom is, it's 80% genetics and 20% lifestyle. That's only true if you follow the usual watered-down public health recommendations. If you're very aggressive, it can really be 90% your own actions and 10% genetics. Most of these genetic dispositions, like heart disease, diabetes, cancer, stroke, you can largely overcome. And it's not a sort of a single silver bullet today. It requires a sort of multifaceted program of nutrition, exercise, stress management, supplements. It's not good enough just to be natural, because the natural program is to age and die. Our genes evolved thousands of years ago when conditions were very different. When our genes evolved, it was not in the interest of the human species for people to live that long, because there was very little food. And if everybody lived to 70 or 80, that wouldn't work. So the human life expectancy was 23. That was long enough for you to raise your kids. Your kids were 12 and ready to go out on their own, and then you died. Everything we've done since has been not natural. We've gone beyond the natural order. That's, in fact, what it means to be human, is to go beyond our limitations.
You predict that in 2045, the singularity will happen. Machine and humans are going to merge. And you plan to be there, to be part of it. You're going to be 97. How come?
Hopefully younger. because we will, it's important to understand the second and third bridge. The second bridge, biotechnology, involves reprogramming biology as if it were a set of software processes. That's basically what it is. We have 23,000 software programs called genes. They were written, quote unquote, evolved thousands of years ago, when, as I say, it was not in the interest of species to live that long. We want to rewrite that code and all of these information processes. I mean, how long do you go without updating the software on your cell phone or your personal computer? Your cell phone updates itself every few days. We have software running in our bodies that hasn't been changed in thousands, sometimes millions of years. We want to rewrite that software. And we didn't even have that software as of a few years ago. Health and medicine used to be hit or miss. It was not an information process. We would just find things through experimentation. Oh, here's something that lowers blood pressure. We don't know why it works. Now, we have the software of life. We're making exponentially rapid progress on understanding it, reverse engineering it. We have the means of changing that software, not just in a baby, but in a mature individual. RNA interference can turn genes off in a mature individual. There are new forms of gene therapy that can add new genes. I'm involved in a project where we take cells out of the body, lung cells, add a new gene, then replicate the cell a millionfold, inject it back in the body, and this has actually cured a fatal disease, pulmonary hypertension, and it's undergoing human trials. There are 1,000 different drugs and processes in the development and testing pipeline to either turn genes off or add new genes or change some other aspect of the information process of biology. This is in an early stage, but one of my theses is that information technology doubles in power for the same cost every year. This has certainly been true of computers. You can just look, recently you can buy an iPhone today that's twice as good for half the money. That's a fourfold increase in price performance just in the last year or two. This has been going on ever since 1890. I put computers on this graph, logarithmic graph going back to the 1890 American census, and it's a very smooth progression of exponential growth. We're doubling the power of computation every year for the same price. When I was a student at MIT, we all shared a computer, took up half a building. The computer in your cell phone today is 1,000,000 times cheaper, 1,000 times more powerful. That's a billion-fold increase in price performance since I was a student. We'll do it again in 25 years. And it's not just computers. It now applies to health and medicine. 15, 20 years from now, we will really be able to completely reprogram our biology away from disease, away from aging.
So that's the second bridge.
That's the second bridge. Right.
And the third bridge.
The third bridge is going beyond biology, not just perfecting biology and reprogramming it, but actually going beyond it. Because even if we perfect biology, it's not as powerful as what we can rebuild if we rebuild matter and energy at the molecular level. That's nanotechnology. One application, for example, is to send blood cell-sized devices inside the bloodstream, little robots the size of blood cells, that just like your white blood cells, that's a little robot, it's a biological one, but it's intelligent, it can find a bacteria and recognize, oh, that's an enemy, and destroy it. But we can actually do a better job because your white blood cell takes about an hour to do it. It sometimes gets confused, there are autoimmune disorders, it sometimes attacks your own tissues, it doesn't recognize every bacteria or virus. We can build new ones that are 100 times faster that can download new software from the internet for new pathogens. And these have been already designed. There are early experiments with nanotechnology inside the body. One scientist actually cured type 1 diabetes in rats with a blood cell-sized device that's nano-engineered, has 7 nanometer pores, lets insulin out in a controlled fashion. At MIT, they have a blood cell-sized device that can detect cancer cells inside the bloodstream and destroy them.
So it's already happening.
Well, these are early experiments in animals, so that it's not yet perfected. It's in an early stage. But it's important to understand these technologies are information technologies. They'll double in power every year. Doubling every year means multiplying by 1,000 in 10 years, 1,000,000 in 20 years. So the golden era of biotechnology, perfecting biology, reprogramming it, that's maybe 15 years away. The golden era of nanotechnology, like blood cell-sized devices.
So when Ray Kurzweil is going to be transferred to a machine, to a computer, what happens to the old Ray Kurzweil?
Well, I don't think the scenario is we take Ray Kurzweil here and we transfer it to some other machine here. It's not going to be that kind of discrete process. It's going to be a gradual process where we add some computers inside our bodies and brains. Those computers have software. At that point, we are a combination of biology and machine. And if that sounds very futuristic, I'd point out that there are people doing that already. Parkinson's patients can put a computer inside their brain that replaces the neurons that were destroyed by that disease. And that has software running on it. The latest generation actually allows you to download new software to the computer inside your brain from outside the patient. That's today. Okay, it's not blood cell size today, it's pea size, but we're also shrinking technology at a factor of 100 3D volume per decade. So these will be 100,000 times smaller in 25 years. So if you go out 25 years and talk to a biological human like you or I, you'll be talking to a cyborg, to a hybrid of biology and machine. And people say, oh, I don't want to combine with machines. They're thinking about today's machines. And I don't want to combine with those machines either, because they're too crude. They're not at human levels. I'm talking about a new level of machine. We probably need a new word. That's just as supple and subtle and complex and rich and emotional as human intelligence. And we will expand our intelligence. We'll make ourselves smarter, remember better, solve problems better. We'll be able to think out on the sort of cloud of computing and automatically access information, put our brains on the internet, and so on. So it's going to be a gradual process.
But at some point, Ray Kurzweil, you are going to exist in what substrate? It's going to be in the web?
You know, there'll be an intermediate period where I'm partly biology and partly non-biology, but it's important to understand the non-biological portion, the machine portion, is doubling in power every year. The biology is not changing much at all. So if you go out far enough, go out another decade, the machine part is far more powerful than the biological part. So and the machine part will be able to simulate and model the biological part. So the biology doesn't really matter anymore. You'll get to a point where the machine part predominates. And that will really be out on the sort of cloud of computing that's already being evolved. And, I mean, what am I today? Even though you say, well, you're this physical stuff, Ray. You know, you're not out on the cloud and web, you're not out on the internet. You're right here, physical, and there's a brain here. But that's actually completely different particles than it was 6 months ago. All the cells die and are recreated. The neurons persist, but the components of the neurons, like the tubules, the filaments, the ion channels, those die in a few days and get rebuilt. We're completely different stuff than we were 6 months ago. There's a continuity of pattern. It's just like, talk about a river. You say, well, is that the same river? The water's completely different. How could it be the same river? Well, the pattern is the same. If you look at the pattern that the water makes around a rock, that pattern can remain the same for hours, for years. But the water changes in a small fraction of a second. But we call it the same river because it's the same pattern. I'm the same person I was a year ago, not because I'm the same stuff, but because I'm the same pattern. Now today that pattern, you know, it all fits in my skull, and but that's just an arbitrary limitation. If we keep the pattern the same, the pattern evolves slowly and gradually. It evolves, but it has. But that's just an arbitrary limitation. If we keep the pattern the same, the pattern evolves slowly and gradually. It evolves, but it has continuity. We ultimately can escape this sort of constraint of having a biological brain in a physical skull that's this big. That's a big constraint. Most of our thinking takes place in the cortex. The cortex is a flat sheet that's about this big. That's actually why humans are superior, because a monkey's is about this big and a mouse is about the size of a postage stamp. So we have a bigger one, but it's still only this big. Why not build a cortex that's far bigger in terms of computational capacity and be able to think grander thoughts? We ultimately will be able to do that.
But you think that we are not going to miss our physical bodies because we are going to be able to create different bodies, and especially virtual bodies, right?
We're going to be spending more of our time in virtual reality. This virtual reality today, you can see it as a harbinger of things to come. Take Second Life. People do everything that they do in real life in Second Life. They go to concerts, they have romances, they invest in the stock market, they do
Sex
all, there's lots of sex in Second Life. So today it's cartoon-like, it's not fully realistic, although it's getting more realistic. If you look at it today versus a year ago, you can see it's getting more and more realistic. Go out 10, 20 years, it won't be a picture over here. It'll be full immersion. We'll be in this virtual reality environment.
All the senses.
We'll have all the senses, because it'll be taking place inside your nervous system. The avatars won't be a little picture. You'll feel like you are that avatar, but it doesn't have to be the same as your body in real reality. You can have a different body in different situations, just like in Second Life. You can have a different avatar for different situations. We'll be spending a lot of our time there. And some of the people you meet will be representations of biological people or cyborgs. Some will be just AIs. That's true already today. The people you meet on Second Life, most of them have biological people controlling them, but some are actually not. Some are just bots that are just software programs. And there's a game going on. How long can you have a bot fool people that it's really not a human? It's another variation of the Turing test. And some can go for, 10, 15 minutes without people discovering that they're human, and they're getting more and more sophisticated. But if we get out to 2029, I believe computer intelligence will be at the level of human intelligence. That has been my claim all along. Computers will be powerful enough, and we will have succeeded in reverse engineering, understanding the human brain and recreating it. There's already 20 regions of the brain that we have modeled and simulated in software and tested those simulations, like the auditory cortex, the visual cortex, the cerebellum, where we do our skill formation, like catching a fly ball,
like
slices.
Obama killing a fly.
Yeah, most of that takes place in the cerebellum. Most of its policy decisions take place in the cortex. There have been slices of the cortex simulated, and that progress is exponential. So I make the case that we will reverse engineer and understand the methods, model and simulate all the regions of the brain by 2029, and that'll provide us the software for human-level intelligence.
No próximo programa, Coswell explica o que é a singularidade, que ele prevê para 2045, e como será o sexo num futuro mais virtual do que real, onde o homem terá cada vez menos partes humanas. Se você quiser saber mais sobre os bastidores desta entrevista, entre no blog do Milênio, no site da Globo News.